Hi, Assalamualaikum warahmatullahi wabarakatuh. I am Awatif Auni bin Zamri. My ID number is 2020877466.
Hi, Assalamualaikum. My name is Auna Nasyirah and my student ID is 2020606656.
Hello, Assalamualaikum. My name is Fatin Ruzana binti Sharon Zaidi. My ID number is 2020457888. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Nurul Anis binti Amran and my student ID is 2020458434.
4,029 kes baru positif COVID-19 yang telah dilaporkan hari ini.
19 as of today, January 20th, 2021. The Health Ministry recorded 4,008 new COVID-19 cases today, January 19th, 2021. The Health Ministry recorded 3,631 new COVID-19 cases today.
Dan untuk itu, kerajaan telah memutuskan untuk melaksanakan Perintah Kawalan Pergerakan PKP atau MCO untuk tempoh 14 hari bermula jam 12.01 tengah malam Rabu 13 Januari 2021.
Berdasarkan kepada peningkatan kes di negeri ini, kerajaan bersetuju untuk melaksanakan PKP, Perintah Kawalan Pergerakan di seluruh negeri Kedah, mulai 12.01 malam 22 Januari sehingga 4 Februari 2021.
What? MCO again? I want to study at university. Oh, I have a call. Who is this? Oh, Anis.
Hello.
Can you guys hear and see me?
Yes, clearly.
How are you guys?
I'm no good.
Why, Awatif? What's wrong?
Our country need to MCO again because of COVID-19, right?
That's why I'm sad too.
Because of that is why we have to do this group assignment virtually.
That's right. I almost forgot that.
And that is why I call you guys. We need to discuss about our group project.
So, what we want to choose to apply geometry in this life?
I suggest that we choose the Sultan Ibrahim Stadium in Johor. The structure of the building is very interesting.
I totally agree with your idea.
Yes, we are agree.
Yes, I'm agree too.
Next, I want to suggest we choose honeycomb to the net cake.
Wow, it is quite interesting. You guys are very creative. I'm so proud of you guys. So, let's start our project.
The introduction. Sultan Ibrahim Stadium is a football stadium in Iskandar Puteri, Johor, Malaysia. It is named in honor of state's current ruler, Sultan Ibrahim ibn Almarhum Sultan Iskandar. The stadium supplements Lakin Stadium, which has housed the current group and all previous Johor football groups since 1964. The full taken toll of the development was assessed at Rm 200 million. The stadium features a capacity for 40,000 onlookers and opened on 22 February 2020.
The design is inspired by the banana leaf and by a crown. The final concept and plan design was disclosed by Tunku Ismail in a ceremony held in Iskandar Puteri, Johor. Its planner is Saadun Designer, was a Beijing established of building design, with the cost of the development of stadium evaluated at 200 million ringgit Malaysia. The Sultan of Johor granted the fund needed for the construction. The stadium spans at 140,000 square meters with a total bid area at 270,000 square meters. The outer frame of this stadium is circle and the shape of this field is rectangle. Discussion 1, question 1. Based on survey and study that we have done, the info and news just tell about the total size area of stadium without telling the diameter for the stadium. So application of geometry used for the stadium is circle. Area of the stadium is 70,000 square meters. Determine the diameter of the stadium. So formula for the circle is pi r square. So substitute pi with 22/7 multiplied by r square equal to 70,000. So r equal to 149.2405 meter. So to determine the diameter, we have to multiply the radius with 2. So diameter we got 288.481 meter.
Next, it is question 2. The question is, Sultan Ibrahim Stadium has a very large football field. Its length is 105 meter, while its width is 68 meter. The pitch needs to be fenced that the ball does not bounce out. The length of the fence is 3 meter. It is the figure of the field. The length is 105 meter and the width is 68 meter. Next, we need to find the perimeter of the field. So, we total 2 multiply 105 and 2 multiply 68 equal 346 meter. The cost to fence the field is Rm100 per pieces. So we find the number of fence needed equal 346 from their perimeter divide 3 equal 115.333, but we must to fit it to whole number equal 116 pieces of fence needed. So total cost is 116 multiply Rm100 equal Rm 11,060 ringgit.
For our third discussion, because of Stadium Sultan Ibrahim is a new stadium, so their supervisor planned to install social zone grass on the field to prevent stagnant water. The price for a piece of grass is 50 ringgit and 50 cents per meter square. So calculate the field area and the overall cost of this project. For question 1, find the area of the field. So area of the field, we just have to multiply 105 with 68 and the answer will get 7,140 meters square. For question number 2, determine the number of pieces of grass needed and the number for fund for that purpose. So, number of pieces of grass needed, we just have to divide the area for the field and the area for 1 pieces of the grass. So, overall, we just get 7,140 pieces of the grass needed to cover for the field. So total cost is 7,140 pieces of grass needed multiplied by 15 ringgit and 50 cents. So we get 11,670.
For the next question, which is question 4, last Saturday, a match between the Kedah team and the Johor team was held at the stadium. Accidentally, 5 players from the Kedah team have formed a polygon as a ball pass technique. The distance between B and C is 1.5 meter. For the question 1, state the name of the polygon. The name of polygon is pentagon. Next, calculate the area of the polygon. First, we need to find an interior angle for the pentagon. So, using the formula n minus 2 times 180 divide n, we got the interior angle which is 108 degree. Next, we need to find the radius which is sin 36 divided by 0.75 equal to sin 90 divided by r. And the answer for radius is 1.28 meter. So, to find the area of polygon, we can use formula 1 over 2 times n times r squared times sin theta. Then substitute and we got the answer which is 3.8955 meter square. A honeycomb is a mass of hexagonal prismatic wax built by honeybees in their nest to contain their larvae and stores of honey and pollen. Two possible explanations exist as to why honeycomb is composed of hexagon rather than any other shape. First, the hexagonal tiling creates a partition with equal size cell while minimizing the total perimeter of the cell. Known in geometry as the honeycomb conjecture, this was given by John Prozac and proved much later by Thomas Hale. Thus, a hexagonal structure used the lattice material to create a lattice of cells within a given volume.
The second reason given by Darcy Wentworth Thompson is that the shape simply results from the process of individual bees putting cells together, somewhat analogous to the boundary shapes created in a field of salt bubbles. In support of this, he notes that queen cells which are constructed singly are irregular and lumpy with no apparent attempt at efficiency. The closed ends of the honeycomb cells are also examples of geometric efficiency, though three-dimensional. The ends are trihedral sections of rhombic dodecahedra with the dihedral angles of all adjacent surfaces measuring 120 degrees, the angle that minimizes surface area for a given volume. Of the sections of honeycomb as shown in the figure 7. Honeycomb is formed of a combination of regular polygons. Given the longest diagonal of each polygon is 7.6 mm, state the name of the polygon and find the area of the honeycomb. Name of the polygon is hexagon. How do we know it is a hexagon? Look at the polygon here. The polygon has 6 vertices, so we name it as a hexagon. Okay, now we want to find the area of the polygon of the figure 7. Given that the longest diagonal is 7.6 mm, so where are the diagonals? Where are the longest diagonals? It is here, 7.6 meters. So we want to find the radius. We need to divide by 2. We get 3.8 millimeters. Okay, now we can use the formula area 1 over 2 n r squared sine 360 degrees divided by n. So we get the answer here. Now we move to question 2. Figure 8 shows a hexagonal shaped cell of honeycomb. Assume that the area of the base of honeycomb cell in figure 7 and figure 8 are congruent. Okay, calculate the volume of the figure below. Okay, we can use the formula B times H, which is B we can get from the question 1. We want to get only area for one hexagon only. So we divide the answer from question 1 divide by 22 hexagons. So we get an area for one hexagon times with H already given to us 25, and we get the answer. Next, 150 grams of raw honeycomb is sold for 44 ringgit. Amelia has 110 with her. Determine whether the amount of money Amelia has is enough or not to buy raw honeycomb with quintuple the volume in one. Okay, first of all, we need to convert the volume from the question 1. So, we need to convert. We divide by 10 and multiply with 5 because quintuple is 5 times. So, we get the volume. Okay, from the given information, we use it to find how much cost for the how much cost of raw honeycomb for the volume given. For the volume we already found. Okay. So we get 137 ringgit. So this means the amount of money Amelia has is not enough to buy raw honeycomb with 68 grams.
In conclusion, we learned that geometry has many practical uses in everyday life, such as measuring perimeter, area, and volume where you need to build or to create something. Geometry also helps us in deciding what material to use or what design to make. Geometric shapes have played an important role in common recreational activities such as sports, video games, cooking, and food design.
We have chosen Stadium Sultan Ibrahim as our first case. The stadium structure was designed with circle shape such as we can see its outer frame and quadrangular shape like the field. As the way all the way know, stadium usually round shape because it would be easier for the onlookers to enjoy watching the match. Polygons such as pentagon has been used by the players in the match as the passing technique. We can summarize that geometry was spread widely in the field of sports.
So for conclusion, in second case, we choose honeycomb. Honeycomb has a unique shape because it formed by the fusion of hexagonal prism, shape cells. His structure provides material with minimal density and relative height, out of plane compression properties and out of plane sheet properties. Nowadays, raw honeycomb have become popular and has its own benefit that allow us lead a healthy lifestyle.
I think that's all from us. In addition, we would like to express our special thanks to our lecturer, Madam Izzaz Raya Sadudin, our parents and our beloved friend who helped us a lot in completing this project. So see you next time and thanks for watching this video. Bye bye.